talking about exponential growth. So in your notes, I want you to write exponential growth. And I didn't turn the graph on. We talked about this is an exponential growth graph, right? This is a graph of an exponential function.
Gary, you spelled it wrong. You put exponential. Oh wait, is that right? Yeah. Never mind.
Okay. And this is a function. For every x, there can only be one y. There's always, and here there's only one place where it crosses the line. One place, one place, one place, one place. Yes. So it's always, it's a function, right? So if I gave you a problem like this, I could write it as y equals, let's just say 8 to the x power, okay? 8 to the x power. How would I graph that? Now, this is interesting. Look where the x is. The x is my exponent. Isn't that interesting? This is not typical. This is not what we've been doing, right? It's because the x is the exponent that we have exponential growth. That's why amazing things, magical things happen. I mean, Albert Einstein said compound interest, which is exponential growth. Compound interest is one of the great miracles or wonders of the world. I can't remember how he worded it, but you know, it's something like that. I think he was sort of kidding. I think he was trying to be funny, but he was also being honest. It's true. It's unbelievable how powerful compound interest is. Yes?
The x is the exponent.
X is the exponent. Right, exactly. You got that. Right? Why don't they just get rid of the E? Exponent, right? No, sorry. Okay, so how would I graph it? I would use a T-chart. T-chart. So we're going to do a T-chart. Here's my big T. Here's my X and my Y. Now, everybody's done T-charts, right?
Yeah.
Nate's group 2? Good. All right. Always a good idea to do a couple numbers in the negatives, right? And then a 0, and then a couple numbers in the positive. Usually a good idea. So I'm going to do that. -2, -1, 0, 1, and 2. Now, remember, why am I choosing to put all my numbers in the X column?
Because the y is
Y is my dependent variable. It's dependent on what I choose for X, right? So I get to, my X then is my independent variable. I can independently choose my X values, right? So I can choose anything I want. If I really wanted to spend a long time on this problem, graphing this, you know, Gideon, you and I might try 1,000,000 here, right? So 8 to the 1,000,000th power, and we could spend weeks, months figuring that out. And then we could finally have our graph, and you could turn it in late and get a 0, right? Or, right? Or we could make them simple. So we choose X values, right, that are sort of simple, right? So let's figure out what is our Y. What's our Y when X is -2? So 8 to the -2. What's our Y?
You have to move it.
Oh, I have to flip
Because
it,
yours
right?
is negative.
So it's 1 over 8 to the 2, which is 1 over 64. That's a fairly tiny number. Don't you agree with me? 1/64th, right? If I cut a pie into 64 pieces and I only could have one piece, that would really, yes, I would agree with that word. Totally. Okay, I can't say it on, this side. Okay, so yes, so we got 1/64th, right? All right, what about 8 to the -1? 1 over 8 to the +1, which is 1/8. You guys agree with me?
Next
All right.
one is 1,
Now, 8 to the 0 power,
which is 1.
everything to the 0 power always equals,
1.
everybody agrees? All right, so it's 1. That's interesting. Okay. Now, 8 to the 1 power,
8.
8, right? Okay, 8 squared,
64.
64. So that's pretty easy, right? Pretty easy. Now, it's kind of important to have these negative signs in here in the x's so that you can see kind of the low end, so you kind of know how to graph it, right? But let's look at our graph. If we graphed it, we have -2. Boom, boom. Okay? And let's see. where do we go? 1, 2? Okay, so this is going to be easy. So negative 2, positive 64. This is a 1. Positive 1/64. That's right around here, right? Don't you agree with me? And then 1/8, that's sort of like right here. Right? Negative 1 1/8, negative 1 1/8. And then 0 1, that's right here. Right? And then 1/8. Right? That would be right here. And then 2/64. Like, I can't do it, but it's like even higher than that. So my graph is like this. It's going to be very, very, very tiny here for quite a while. And then eventually it's going to start to curve up. And it's going to go up pretty darn fast. Boom. My exponential growth, right? That's how you graph it. Piece of cake, right? To graph these? Piece of cake. So you're going to have a few of those to graph on homework tonight. Can I erase this?
Yeah.
Okay. Let's see, what am I doing? I'm erasing all of it. Exponential growth. Okay, so now let's talk about the exponential growth function. Let me write it over here. Exponential growth function. Now my class has learned this, but it's been a while, so I'm sure they don't remember it too well. This is the function. Y is equal to A, parenthesis, 1 plus R, parenthesis, raised to the t power. So write that down and I'm going to explain it to you. Actually, while you're writing it down, I'm going to quickly write down the problem. So actually, hang on, I'm just saving time because I know. I'll finish that in a second. So let's just talk about the anatomy. You guys, I've said this many times, the anatomy of an equation, right? Anatomy means like the different parts of it, like anatomy of a body is your head and your nose and your, what is that again? Shoulder, right? Elbow, hands, knees, right? Well, the anatomy of this, what is everything? So the anatomy of this, well, y is just your final answer when you plug everything in, right? It's your final value. What is something worth a few years from now given a certain interest rate, right? Or something. So we're going to talk about money right now. But we could be talking about rats, right? We could be talking about mice. We could be talking about ants. We could be talking about anything that grows exponentially, right? You start with 2 and suddenly things happen, right? And you get more. And then all of the things happen with all of them, and then you get more and more and more and more, right? And it grows exponentially, right? So A is your initial, excuse me, wait a minute, I'm on initial vertical velocity. A is your original amount. Your original amount.
I remember that.
Okay? 1 is 1. Ha ha, that's great.
Whoa.
Can you remember that? Okay, R
What is your rate?
is your interest rate, right? Your interest rate,
And T is your time.
and your interest rate is usually, in this particular case, we're talking annual, okay? And your T is your time, exactly. And your time is usually in years here, okay? It's not in seconds, right?
What if
We're talking-
What if
we're-
we're lucky and it triples every second for 20
So
years?
then, yeah, you could actually use this and change the time to not just years, but you could make it seconds if you needed to, right? So you can do that. That's fine. But in most cases, you're going to use this formula as an annual kind of thing, right? So let's
You'd be
what did I do with the book?
you'd be
So-
so much
So start writing this word problem, because we're running out of time. We're gonna actually do one word problem and quickly finish this. So you put $250 in the savings account. That earns, is this, hang on, I gotta see if this is still on. That's on, I better go over here. That earns 4% annual, how did they word it? Okay, 4% annual interest, and they're gonna say this word compounded, because this is a compound interest formula, compounded annually. It's a slightly different formula if you're compounding monthly. But so this is a sign that if when it looks like that, it's an annual compounded annually. Okay, where is it? And annually means yearly. You guys know that? All right, so you make no deposits and withdrawals. Okay. So in other words, the money just goes in there and sits. So no deposits, no withdrawals. You don't take any out, you don't add any in. Right? Period. So then the question is, how much will your investment be worth in 5 years? Question mark. I'll give you a second to write that down, if you haven't already. Put $250 into a savings account that earns 4% annual interest. Is that even common today? Savings
This
is
would be like 0.1%.
Yeah.
yeah.
Point
Yeah.
zero.
When I was younger, it was easy to get 5% in a savings account. Easy. It was common. 5, 6, 7. I even got 7% in savings accounts. And then something happened, and I never quite understood what. But it dropped to nothing practically. 0.05% and 0.1%. Really crazy stuff. So anyways, yes. So are we ready? Can we do our equation? So first I'm going to copy my equation here for a second. I've got y is equal to a parenthesis 1 plus r raised to the t power. Okay, so my final value is y. That's what I'm being asked to find, right? What's your investment worth? That's my y. So I get y equals, what's my initial amount?
250.
250 parenthesis times.
1 plus 5.
All right, 1
No,
plus
4. 0.04.
0.04, right? You want to write the 4% as a decimal, not as a percent, right? Right? So you write 0.04 parenthesis raised to the t, fifth power. All right, now what is 1 plus 0.04? 1.04. Oh my God, that's so easy. Oh, thank God you guys knew that. You saved me hours of time. Oh yeah, so that's really the same thing. 1.04 is the same as 1 plus 0.04. Cool. So now I get out my handy dandy phone or calculator, right? And maybe I'll do it this way first. I'll do this first and then I'll multiply it times the 250. So I'm going to say 1, in my calculator I'll do this, 1.04, and then I'm going to do my button, whatever button you have, right? I have the y to the x, Oliver has the x to the y, and Nate has the caret, right? So you do 1.04, and that, or this, or, right, the caret, which is this, and then, what do I put here? 5, right? Because that'll be the y, that's the exponent. 1.04, this, that, and then times 250.
So do we do that?
And if you did that, I don't know the answer. Well, I guess I do.
It's
Is this
1.04
on the-
to the.
Oh, wait, is this So y is equal to what is it?
304.163225.
Okay, so I'm gonna just round it because money doesn't go beyond the hundreds, right? So I'm just gonna round it to $304.16. So in 5 years, my $250 raised $54.16. And I didn't have to do anything. It was awesome, right? I wonder what it'd be in 10 years. What would it be in 10 years? I'm just curious.
No, it won't be double, actually. No, you don't double it.
So in 10 years, this was 5 years. This was 5 years, right? 10 years, 304.1, oh, wait, sorry, 250, well, you got it. Tough.
370.06.
370.06, look, the second year, instead of 54, I made $66, right?
Wait, that's.
The second 5 years.
In the second 5 years, I made $64 instead of just 50, or $66 instead of $54. And if we kept going, you'd start to see that increasing each time, right? Every 5 years, it's going to be substantially more. Eventually, it's going to be a lot of money, okay? So that's great. So that's it for today. Oh, the homework is on the board right here. You don't, all except number 4. You don't have to do number 4. But, so it's on page 524, numbers 9. Can you see this? 524, numbers 9, 10, 22, 24, and 34.
Wait, number 9, 10, 22, 24.
9, 10, 22, 24, 34. And page 525.
Did this finish recording?
Okay, 525.
Maybe.
Oliver, you should be.
Page 525,
What's that?
it's 38 and 39. All of this is right.
Okay.
And page 526, number 43.
And do not leave until you've given us your homework.
Oh, homework?